Welcome students. Today we are going to solve some more problems related to bond valuation. So this is the problem we have. Arvind considers rupees 1000 par value bond bearing a coupon rate of 11% that matures after 5 years. So the par value is 100,000, coupon rate is 11% and mature rate is 5 years. So he wants a minimum yield to maturity of 15%. The bond is currently sold at rupees 870. Should he buy the bond or not? That is the question. So let's solve this. Okay. So let's write the formula. So we know P is equal to N summation T is equal to 1 C divided by 1 plus R raised to T plus M by 1 plus R raised to N. Or else we can use the simplest formula, that is C coupon rate into present value interest factor NET R into N plus M present value interest factor R N. Okay, so let's fill the values in the formula. So is equal to, so the coupon is the par value is 1000 and 11% is interest. So the C is equal to 110, M is equal to 1000. Okay, R is 15%. Number of years are 5. Okay, so with the data we have to calculate uh, the present value. So let's put it in a formula. So is equal to, so we know C, that is 110 into bracket. So present value interest factor annuity, that is for present value interest factor annuity 15% for 5 years plus 1000. I will continue here into present value interest factor 15% for 5 years. So by putting this 110 into, and I'm comparing here the table, that is present value interest factor annuity 5 year 15%. So from that I will get the value, that is 3.352 into plus 1000. Again, I'm referring the table for 15% 5 from the present value interest factor. So here I get 0.497. So is equal to, this will be 368.7 plus, and this will be 497. So is equal to 865.7. So the value, present value is 865.7. So if you look, the bond is currently trading for 870. So which means, so he should not buy the product, because the anticipated minimum yield 15% of the price should be rupees 865.70, but the market price is very higher. If we compare the market price, the present price is 865.7 and the market price currently traded at 870. So this is higher. So he should not buy the product. So Arvind should not buy the bond. So this is the solution for the problem. So now we are with the another problem. So here we will calculate YTM, that is nothing but yield to maturity. So let's solve this. So the market price of rupees 1000 par value bond carrying a coupon rate of 14% and maturing after 5 years is rupees 1050. Now what is the yield to maturity on this bond that we have to calculate? And one is the yield to maturity, and second question, what is the approximate YTM, and what will be the realized yield to maturity if the reinvestment rate is 12%. So let's calculate. One thing always remember, yield to maturity always commit the trial and error method just to calculate. And when we are going to calculate approximate, and there is a standard formula, we take it for calculation. Now let's put it in a formula. So we have the basic formula first is, okay. So we know what will be the value. The value is 1050. Okay, that is given in the problem. Okay, and we have to calculate R here. That is missing. That is yield to maturity. So here comes the 5-year summation time is equal to 1. Okay, so C we know that is 14% of 1000 is 140 divided by 1 plus R that we need to find out. Okay, for T that is nothing 5. So plus 1000 par value divided by 1 plus R is to 5. So this is what we know, and we need to calculate R from that is nothing but yield to maturity. So this can be solved with the trial and error method. Now if it is 1000 and the value required is 1050, so we'll go with the two trial and error method. So first we will go for 13%. We'll check. You can try 11, 12, 13, 14. So we can first go and check with 13% putting R. So this same problem can be written as 140. Okay, present value interest factor annuity. We don't know the percentage, that is R, and for 5 years plus 1000 present value interest factor R for 5 years. Okay, so first let us try by taking R is equal to 13%. So I will put it in the formula, that is 140. Okay, present value interest factor annuity 13% for 5 years plus 1000 present value interest factor annuity 13% again for 5 years. So 140 into taking 13% from 5 years from the table. So the value I get is 3.517 plus 1000, and present value, there is a mistake, sorry for this, writing the formula. Okay, there should not be annuity here, I'm sorry for this. So 1000 into present value interest factor for 13% for 5 years. So from table I take the values, so that is 0.543. Okay, so got the value. So let's multiply 140 into 3.517. So I get the value that is 492.38 plus 1000 into 0.543. So I'll get 543. So by totaling both the values, so we get the value that is 1035.38. But if we look at actual, so that is 1050. So now we need to reduce the percentage R, but it is nearby. 13 is nearby to 1050. So now reduce it to 12%. So we will check it with 12%. Now put the same values in for calculating for 12%. So now here we consider R is equal to 12%. So let's put it in this formula. So 140 into present value interest factor annuity 12% for 5 years plus 1000 present value interest factor for 12% for 5 years. So 140 into this value, I will get it from table, that is 12% 5 years from present value interest factor NAT. So I get the value that is 3.0605 plus 1000. So again, I will refer the table here. By referring the table, we get the values that is 0.567. Okay, so let's multiply this 140 into 3.605. So we get 5 not 4.7 plus 1000 into 0.567, that will be 567. So is equal to plus 567 1071.7. So by looking the two values, this is 1071.7 if you put 12%, and if you're putting 13%, it is 1035.38. So the value for yield to maturity is between these two. So now we will put into the formula to calculate it linear interpolation. So let's put this in linear. Okay. So now thus, we'll write a comment here. Thus, R lies between 12% and 13%. So we use using linear interpolation in this range. So let's do it. So how to do 12%? That is the highest we got, plus 13% minus 12. Okay. So when we did this, so 1071.7 for 12% minus 1050 for 13%. So 1071.7 minus, that is the highest value, so 1035.4. So this is the value which we require, and this is the value we have calculated for 13%. So by doing this all calculation, so we get the data that is 12.60%. So that is the yield to maturity. Now the second question says, what is the approximate? Okay, approximate YTM to solution to question B. Calculating the approximate YTM. Okay, so let's, the standard formula for this YTM is equal to, so here we know that there is an exact formula to calculate YTM. So let's do that. So is equal to C plus F minus P divided by N whole divided by 0.4 into F plus 0.6 into P. So this is the formula we will use to calculate approximate YTM. And if in exam he is asking just YTM, so you can use this formula or you can go for trial and error method. So best you try for YTM, then you can go for trial and error method. So you can get to know exactly where it lies between two of the values or a percentage. So let's put the value here. That is we know C. So C is 140 plus F. So fair value is 1000 minus the present value is 1050. That is what required. Okay, divided by N, that is 5 years. So whole divided by 0.40, okay, into 1000 plus 0.60 into 1050. So if we simplify this, so we get the value. Okay, so after simplification of this all, so here if I do 140 plus 1000 minus 50, so it is 1000 minus 1050, so that is minus 50. So minus 50 divided by 5, okay, and here I get 400 plus, and here I get 0.6 into 1050 is equal to 630. So 140 minus 10, because 50 divided by 5, so it is minus 10, and whole divided by, that is 1030, so is equal to 130 divided by 1030, so is equal to 130 divided by 1030 is equal to, so we get 12.62 percentage. So if you take this value, so we get YTM, that is 1050. Solution for the approximate formula. Now let's move to the third question. And third question asked in the problem was, what will be the realized yield to maturity if the reinvestment rate is 12%? So let's calculate this. So C is equal to solution for C. Okay, the realized yield to maturity may be calculated as follows. So we know coupon rate is 140, and the 12% is that is what is replaced. So it is 1.124. We have to calculate it for 5 years. So again 140, 1.123 plus 140, 1.12 into 2, and 140, 1.121 plus just 140 and plus 1000, the value of the bond, par value of the bond. So is equal to, after simplification, so we get rupees 1889.39. So we know the value, how much it is, and we have to calculate the realized yield to maturity. So we use this present market price, that is 1 plus R 5 years into market price, present market price is equal to, that we know this we get realized one 1889.39. So we know present market value, that is rupees 1050, and 1 plus R is to 5, so is equal to rupees 1889.39. So let's put just 1 plus R 5 here, and we will take 1050 that side. Okay, we'll take 1050 that side. So 1889.39 divided by 1050. So we get the value that is 1.7994. 1 plus r raised to 5. So let's continue again to the next page. So now what we'll do, we'll keep r here. Okay, and we are taking the last term, taking 1 and raised to 5 that side. So it will be 1.7994 1 by 5 minus 1. Okay, so is equal to, the value we get is 1.247 minus 1. So is equal to 12.47%. So this is the realized value. This is the end of the problem. Let's see another problem, that is here it is Prem is considering the purchase of a bond currently selling at rupees 878.50, and the bond has 4 years to maturity. Face value is rupees 1000 and 8% is the coupon rate. And the next annual interest payment is due after 1 year from today. So the required rate of return is 10%. So the first question, calculate the intrinsic value, that is present value of the bond. Should Prem buy the bond or not? So let's put it in the formula. So first solution A. So we know the formula, so let's directly calculate it. So C into present value interest factor annuity, R into Y plus M into present value interest factor, that's R, Y. So C we know 80, okay, into present value interest factor annuity for 4 years, and that is for 10%. So we get the value, that is 3.1699 plus 1000 into present value interest factor annuity, that will be 0.6830. So is equal to, so we get the P value, that is intrinsic value, that is rupees 936.592. So we get the value, that is rupees 936.592. So the asking whether to buy it or not. So intrinsic value is, if you see, that is 936.56. Sorry, 936.596, and the market price of the bond is rupees 878.50. So the bond is underpriced. So Prem should buy the bond. So we can comment market price is rupees 878.50, and the present value is rupees 936.592. So Prem should buy the bond. Now let's calculate second question. What is the calculate the yield to maturity of the bond? So with the same data, he is asking us to calculate yield to maturity. So here we need to take 878.50 as a value. So let's calculate. So we'll go with the direct method, approximate calculation method. Okay, that can be easy for us. We can do that. So let's do it. So we know the formula. So YTM is equal to, sorry, YTM is equal to C plus F minus P divided by N whole divided by 0.4 F plus 0.6 P. Okay, now we know the C value, that is 80, plus we know F, that is 1000, and 878.50 is the market price, and it is for 4 years. So divided by 0.4 into 1000 plus 0.6 into 878.50. So we get value, that is 80 plus 1000 minus 8, we get, that is 1000 minus 878.50. So we get 121.5 divided by 4. 4 divided by 400 plus 878.5 into 0.6. So we get 527.1. So 80 plus 121.5 divided by 4. So we get 30.375 divided by 400 plus 527.1. So 927.1. So is equal to, so 80 plus 30.375 is equal to 110.375 divided by 927.1. So is equal to 110.375 divided by 927.1. So we get the value, that is 11.905%. Or else we can even treat it, which is very near to 12. So that will be 12%. But approximate value is 11.9. So it will be 12%. So this is the solution for the problem.